Imagine you are sitting in your living room and you have noticed that on your skin there is a strange coloration. You immediately take a picture of it and then you upload it into your favorite AI health app. And the app tells you that this looks like a type of fungus and you need to go to the pharmacy and buy a certain medication and apply it in a certain way. Now, this is of course relieving to have access to such an AI doctor, so to say, but we need to understand what goes on behind the scenes when this decision is being made. My name is Zeynep Akata. I'm a professor of computer science at the Technical University of Munich. I am the director of the Institute for Explainable Machine Learning at Helmholtz Munich. I'm a PI at Munich Center for Machine Learning. A foundation model, you can think of it as like a mirror to the society. If the mirror is distorted, then the image that comes out of it is going to be distorted too. So if the data that is being used doesn't reflect the true extent of the society, then the model is going to be biased to what it sees to learn patterns from the data. Part of my research is focusing on measuring and mitigating these biases. Maybe in the past, explainability was thought of like an X-ray mechanism. You have the model and you X-ray it and you see what the model has done before. But I instead would like to treat this learning mechanism as a steering wheel. So the explainability becomes the steering signal for learning. And these models are refined again and again every day. And we are seeking for ways to do this in a controlled manner. So mechanistically, it's a bit like neuroscience done on machines, where you need to try to understand which parts of the model, which neuron, for example, was responsible for recognizing a certain concept. Then we can go back and see, okay, what was wrong about that decision, which part of the pattern was recognized incorrectly. Then I go back to the neuron that is responsible for detecting that pattern, and we could change the way it is computed, change our learning algorithm to do that. We can play with its uncertainty assignment mechanism, so the model knows that it is not really certain about making that sub-decision before communicating it to the rest of the model. It's like a sequential decision-making mechanism. If one part is wrong, then the whole process gets diluted by the wrong decision. Because these foundation models are permeating in our lives, we can't just choose not to use them. They are a part of our lives. Foundation models can improve us. They can make us faster in making decisions. So we can work together with them to also create a better society. But to be able to do that, we need to be able to trust them. They need to be safe. So safety in AI is one of the most important dimensions that is driving me in my research.